Okay, let's talk about 6.4 number 1. So 6.4 number 1 says, use the theorem of Pythagoras to find the length of the line segment y equals 2x from 1, 2 to 2, 4, and confirm that the value is consistent with the length computed using formula 4 and formula 5. Okay, so I gave you both of those formulas in the notes, but I didn't label them formulas 4 and 5. So this is what they're talking about. Formula 4 here when you're integrating with respect to x, and formula 5 is here when you're integrating with respect to y. Okay, so let's do this. What? Okay. So this is 6.4 number 1. And so we're working with the function f of x equals 2x from 1, 2 to 2, 4. So we want that line segment. And the first thing that the problem asks us to do is to find the length of that line segment just using Pythagorean theorem. Okay, so I'm going to draw a picture real quick. It's always useful to have one. So 1, 2, and then 2, 4. So we're talking about this line segment right here. So when they say to use Pythagorean theorem, what they mean is we can think of this like a right triangle. Okay, and this length is obviously 1, this length is obviously 2, and then we want to find the distance there. Well, we can say x squared plus y squared equals d squared. In other words, d squared is 5, so then d is square root of 5, right? So that's what we get when we use Pythagorean theorem. And now we're being asked to verify that you get the same thing if you find the length of that line segment using the techniques that we talked about in 6.4. So we'll start off by checking it when we integrate with respect to x. So integrating with respect to x, the length of that segment should be the integral from 1 to 2, right? 1 to 2. So the integral from 1 to 2 of the square root of 1 plus f prime of x squared. Well, if f of x is 2x, then f prime of x is just 2, right? Dx. And let's see. This would be integral from 1 to 2 of square root of 5 dx. That's going to be square root of 5 times x evaluated from 1 to 2. That's going to be 2 root 5 minus root 5, which is just root 5. Okay, so that one works. And then they want us to also check it when we integrate with respect to y. I guess differentiate as well, right? So if we do that with respect to y, the length of our segment is going to be the integral from 2 to 4 this time, right? From 2 to 4 of the square root of 1 plus g of y, g prime of y. So first of all, I need to get this line segment in terms of y. So in terms of x, it's y equals 2x. So if I solve for x, I'm going to get x equals y over 2, or 1/2 y. So g of y is 1/2 y, and that means that g prime of y is 1/2. Okay, so it's going to be 1 plus 1/2 squared dy. 1/2 squared is 1/4. 1 plus 1/4 is 5/4. The square root of 5 over 4 is going to be the square root of 5 over the square root of 4, or in other words, the square root of 5 over 2. So this is going to be integral from 2 to 4 of root 5 over 2 dy. So I can integrate that. I'm going to get root 5 over 2y evaluated from 2 to 4. If I plug in 4, I'm going to get root 5 over 2 times 4. The 2 will cancel 2 and leave a 2, so I'll get 2 root 5. And then if I plug in the 2, root 5 over 2 times 2, the 2's will cancel and just leave a root 5. And 2 root 5 minus root 5 is again root 5. So that one also checks out. So that's 6.4 number 1.